We're going to go to France. So bonjour, Jahrl, are you there?
Yes, I am.
Wonderful.
Bonjour tous. Voilà.
And you're about to share your screen. You are doing very well. So take it away.
Exactly. I succeeded in that. So I think I get some points for that. So my name is Jahrl Norberg, the Swede in France, as Magnus said. So I'll try to give you a view of what we do in AI in industrial automation. And we're working on Edge that we already write here. So I am the Chief Business Officer and co-running KAPSDATA. So I'm essentially responsible for our market development, but also our technology incentives. Here, if I get to move to next. So we're a small team of engineers based up in north of France and in the US. And we have become expert in some specific segments. We're working with analytics. And specifically, I want to say immediately, we work on improving industrial processes, and we're focusing on the view from the user. So we're less on exactly the equipment, but we're from the user point of view. So I will bring you in directly into a use case in order to show you what we do. So perhaps a little bit techy, but not too much. So we have a lot of experiences in large data centers, and I will show you something else before that. So, okay. So we're having large experiences in data centers, and we provide something that we call process intelligence. And with what we say process intelligence, we combine four things: AI, industrial IoT, in real time, and with an edge architecture, in order to unlock what we call process performance in both manufacturing industries, in data centers that I will show you here, but also in technical buildings. And our technology is called KAPSTech. It's a toolkit based on open source tools and softwares, but also in industrial IoT. And it's about moving the focus away from monitoring or trending the technical performance of equipment, but to manage some sort of an end-to-end performance of the industrial process, and to do that in real time. So we're not providing a software license. We're providing, it's true, a result, but we're selling a technology, and we're integrating a technology. So our solution, we're creating what we call the spots, and I will mention that a little bit more. So the single point of truth to provide decision or decision material to actions, to really act on, for example, energy consumption, predictive maintenance, or total cost of ownership, but also on the environmental footprint. So here is the use case. This is a data center. It's a portion of the data center is 2.5 megawatt. There are two parts of this. It's a so-called tier 4 data center, which is very redundant. So we have the complex system that is in very small format on the left. We're creating the formats of what we call the data acquisition. So we're creating a metadata management and also partially a data quality management in order to gather many unique sources of measurement. They are very often independently created by different portions of equipment. And we're setting that together into a non-structured database. So we're creating an overall database. It's on SQL in order to create models and to work with that in order to affect the performance. So if we look at this graph that doesn't exist in reality, it's a graph that shows the power consumption of the cooling system in this data center. So what we will see on the left side is the power consumption in kilowatts, and on the lower side is the external temperature. And it goes from -10 up to 30, if you can see the figures. A data center, the production in the data center, it's really the IT load, the servers, the storage, and the computing. And the rest of the data center is what we call infrastructure. And that infrastructure is essentially composed by cooling equipment. It's about cooling these servers and so forth that are heating. So by providing that cooling, the production works. Now, how can we provide an optimization of this cooling, of this infrastructure? So the blue dots on this graph is represented, and by classification is representing what we call the free cooling. The free cooling means that we take air from the outside and put it into the IT equipment to cool it, simply. But it's free cooling. That means we're not using any equipment to create cooling. It's just taking air from the outside with fans, simply said, to pull it inside. That goes from -5 up to 5 degrees, and it consumes something from 0 up to 200 kilowatts. The red spots or red dots are when it's warmer. It's here from 8 up to 15 degrees, and that's where when the chillers are working, that means active cooling. The active cooling is, of course, then consuming more power, and in this case, something from 250 up to 350. The green dots are what we call in between. So it's an in-between mode where both free cooling and active cooling is used. So these green dots are what we call the good mode. So the good mode means that that's where we would like to be. The orange spots are what we say the bad mixed mode. What we do is to bring the orange bad mood dots down to the green ones. That's the action. So what we're creating with these KAPSDATA key indicators, there are only 2 of them, but 2 groups. The first one is performance, and performance means level of something. So if we talk about energy, energy consumption is then a value, but we're defining what it is. Is it bad, good, or excellent? That is very rarely known. There are no alerts, there are no red lamps, everything is green, everything works, but the performance of energy may be crap. The second indicator is the action to do something about it. It's about giving to the operational team or loop back to the equipment to change from bad mode up to good mode, or maintain a good mode if the prediction is that the performance, for example, in this case, energy, is about to degrade. We're using our single point of truth. That means our system that we created from the unique sources of measurements in order to create a model, and by AI partly, it's not AI to do AI, it's AI to create a result, is to optimize the performance, in this case, energy, as we mentioned. So if I take just an example, we're working in data centers, we were starting working directly with operators, and now we're developing our business to work with integrators as well as industrial partners. So if I just take an example, ABB is providing both automation and equipment to different areas, also for data centers. And what we're adding is that we are correlating the usage, that means the user environment, with the function. And the function is composed by 2 things, the equipment plus the application. Someone providing an equipment doesn't always have the grasp of the application, and for sure, very often, he doesn't have the view from the user. So the performance optimization in our case is to optimize from the viewer point of view. So the equipment can work very well, but the performance for the end user can be very bad. So if just thinking of a data center, we then have our modeling working on non-structured data, and we're creating this single, this spot, and we're having an installation, and we're providing the action, and don't pay attention to the ABB ability as such, but we're giving the action to either the operational team or directly into equipment. And in this case, we're creating a value. We essentially have the large experiences in data centers. So we're working with the nuclear organization in France, for example, in south of France, it's an 8 megawatt data center. We're working in Luxembourg. We've even been creating some small data centers, but we've also already have experiences in large office buildings. For example, the Montparnasse in the center of Paris is a 49,000 square meter building, where we could in fact do a 30% decrease of the energy consumption of the infrastructure of the building. We've also worked with a French rail company, SNCF, where we have been working with maintenance halls. This case was a 7,000 square meter maintenance of complete trains, where we were taking down energy usage with 53%. It's gas heating. And we've also done some specific projects on moving vehicles. So we're starting to talk about KAPSTEC by KAPSDATA, AI insight, to copy a little bit the interview. Sorry. So
Great.
Thank you for your time.
Thank you so much. Very interesting. I'm so happy you're with us. I hope we can provide you with some good content into new companies to deal with